Okay, this is number 9 from 8.2. Put it right there. And we're supposed to come up with the equation of this curve, or this graph. What does it look like? A couple of things I want to point out just to begin with. And let me get to my draw. There we go. It looks like we have an asymptote here at 0, and an asymptote here at pi. So what I want to look at is, I mean, even looking at the shape where it comes from high and goes down, comes from high and goes down. If I look at this in terms of, let me get the, here it is. Okay, so I look at this graph right here. It looks very similar. So we have, it looks like an asymptote here at x equals 0, then over 1 at x equals pi. And so we're seeing that curve. So I'm going to go back to the curve we have. And I say this, it means we're not shifted horizontally. Looks like we are falling within normal attributes for, and you can see this here, a cotangent function. If I can get my mouse back there, it's a cotangent function. Now, a couple of things to think about. Add pi over 2, x is 0. Sorry, y is 0. Gosh, if I can think today. At x is pi over 2, y is 0. Another thing, so keep track of that point. At x is, this would be halfway there, so pi over 4, y is 1, and x is 3 pi over 4, y is -1. So I'm going to focus on this one to see if we have a vertical shift, and then we can see if we have any stretching going on. So right off, we're working with a cotangent. So y equals cotangent x is the base function. And there's no horizontal shift. Okay, I'm going to go to blue because I don't like red that much. Now, some points we know we would normally have in a standard non-shifted function would be pi over 2, comma 0. We would have pi over 4, comma 1. And we would have 3 pi over 4, comma -1. Okay, so let's see what we have. I'm noticing the 1 is occurring here at pi over 4, so that actually checks. However, normally it would be going through 0 at pi over 4, but where it's crossing is actually down here a little bit further, which is 2 down. Okay, that's interesting. That implies some kind of a shift. And then this 3 pi over 4 is not hitting at -1. It's hitting down here at -5. Interesting. So what we're seeing is pi over 2, and I say air quotes crossing, it looks like where it would have hit 0 is now shifted down to -2. If that's making sense when I try to say that. Pi over 4 is still at 1. And then 3 pi over 4 is at -5. So when I think about that, now, given that this location here would have been 0, multiplying by any number is not going to change a 0. So that looks like it's definitely a shifted down. So I think we could say it's y equals something times cotangent of x minus 2. The thing is, what is this going to be? Now, normally this value here, this -5, would have been at -1. But let's just walk this. If we had it at -1, and then it shifted down 2, but now it's down here. Or maybe we should think of this like this. We take this 1, and we multiply it by something first, and then we take 2 away from it. So we have -5. If we add 2 back to that, we would be at -3. So we could think of that as being shifted down by 3. Or not shifted, stretched by 3. Okay. Let's go the other direction. That pi over 4, so cotangent of pi over 4, would have given us 1, sure. But let's talk about if we were to have multiplied that by 3 times cotangent pi over 4, that'd give us 3 times 1, which is 3. And then if we subtracted 2, that gives us 1, so that puts us where we are. So I'm going to propose that this is actually y equals 3 times cotangent of x minus 2. And that is actually the value there. So what I look at is it's not horizontally shifted. I can see a physical moving down of the thing where it would have been 0. It's physically moved down by so much. So then if I account for the other points being moved down by 2, means this would have been 2 up there. This would have been 2 up there. Then by multiplying by 3, then times 3. How do I say that? There, that's what I wanted. Times 3. Probably making this worse now, just trying to explain it. Times 3, negative 1 times 3 is negative 3. 1 times 3 is 3. That gives us those stretches. Then the vertical shift is what brought it down. So that is finding the equation of this graph.